A vehicle identification number, commonly abbreviated to VAN, or chassis number, is a unique code including a serial number, used by the automotive industry to identify individual motor vehicles, towed vehicles, motorcycles, scooters and mopeds as defined in ISO 3833. VAN were first used in 1954. From 1954 to 1981, there was no accepted standard for these numbers, so different manufacturers used different formats. In 1981, the National Highway Traffic Safety Administration of the United States standardized the format. It required all over-the-road vehicles sold to contain a 17-character VAN, which does not include the letters I, O, or Q. There are vehicle history services in several countries that can help potential car owners use VAN to find vehicles that are defective or have been written off. See the used car article for a list of countries where this service is available. VAN classification. There are at least 4 competing standards used to calculate VAN. FMVSS 115, Part 565, used in the United States and Canada. ISO Standard 3779, used in Europe and many other parts of the world. SAEJ 853, very similar to the ISO standard. ADR 61 halves used in Australia, referring back to ISO 3779 and 3780. Components of the VAN. Modern-day VAN systems are based on 2 related standards, originally issued by the International Organization for Standardization in 1979 and 1980, ISO 3779 and ISO 3780, respectively. Compatible but somewhat different implementations of these ISO standards have been adopted by the European Union and the United States of America, respectively. The VAN is composed of the following sections. World Manufacturer Identifier. The first 3 characters uniquely identify the manufacturer of the vehicle using the World Manufacturer Identifier or WMI code. A manufacturer who builds fewer than 500 vehicles per year uses a 9 as the 3rd digit, and the 12th, 13th and 14th position of the VAN for a second part of the identification. Some manufacturers use the 3rd character as a code for a vehicle category, a division within a manufacturer, or both. For example, within 1G, 1G1 represents Chevrolet passenger cars, 1G2, Pontiac passenger cars, and 1GC, Chevrolet trucks. The Society of Automotive Engineers in the U.S. assigns WMIs to countries and manufacturers. The first character of the WMI is the region in which the manufacturer is located. In practice, each is assigned to a country of manufacture, although in Europe the country where the continental headquarters is located can assign the WMI to all vehicles produced in that region. In the notation below, assume that letters precede numbers and that 0 is the last number. For example, 8x82 denotes 8x, 8y, 8z, 81, 82. In particular, this does not include 80. Country codes. Vehicle descriptor section. The 4th to 8th positions in the VAN are the vehicle descriptor section or VDS. This is used, according to local regulations, to identify the vehicle type, and may include information on the automobile platform used, the model, and the body style. Each manufacturer has a unique system for using this field. Example: for the 2007 Chevrolet Corvette U equals 6.0 LV8, E equals 7.0 LV8. North American check digits. One element that is fairly consistent is the use of position 9 as a check digit. Compulsory for vehicles in North America, and used fairly consistently even outside this rule. Vehicle Identifier section. The 10th to 17th positions are used as the Vehicle Identifier section. This is used by the manufacturer to identify the individual vehicle in question. This may include information on options installed or engine and transmission choices, but often is a simple sequential number. In North America, the last 5 digits must be numeric. Model year encoding. One consistent element of the VIS is the 10th digit, which is required worldwide to encode the model year of the vehicle. Besides the 3 letters that are not allowed in the van itself, the letters U and Z and the digit 0 are not used for the model year code. Note that the year code is the model year for the vehicle. The year 1980 was encoded by some manufacturers, especially General Motors and Chrysler, as A, yet Ford and AMC still used a 0 for 1980. Subsequent years increment through the allowed letters, so that Y represents the year 2000. 2001 to 2009 are encoded as the digits 1 to 9, and subsequent years are encoded as A, B, C, etc. On April 30, 2008, the U.S. National Highway Traffic Safety Administration adopted a final rule amending 49 CFR Part 565. So that the current 17-character vehicle identification number system, which has been in place for almost 30 years, can continue in use for at least another 30 years. In the process making several changes to the van requirements applicable to all motor vehicles manufactured for sale in the United States. There are 3 notable changes to the van structure that affect van deciphering systems. The make may only be identified after looking at positions 1 to 3 in another position, as determined by the manufacturer in the second section or 4 to 8 segment of the van. In order to identify exact year in passenger cars and multi-purpose passenger vehicles with a GVWR of 10,000 or less, one must read position 7 as well as position 10. For passenger cars, and for multi-purpose passenger vehicles and trucks with a gross vehicle weight rating of 10,000 pounds or less. If position 7 is numeric, the model year in position 10 of the van refers to a year in the range 1980 to 2009. If position 7 is alphabetic, the model year in position 10 of van refers to a year in the range 2010 to 2039. The model year for vehicles with a GVWR greater than 10,000 pounds, as well as buses, motorcycles, trailers and low-speed vehicles may no longer be identified within a 30-year range. Van characters 1 to 8 and 10 that were assigned from 1980 to 2009 can be repeated beginning with the 2010 model year. Plant code. Another consistently used element is the use of the 11th character to encode the factory of manufacture of the vehicle. Although each manufacturer has its own set of plant codes, the location in the van is standardized. Production number. In the United States, the 12th to 17th digits are the vehicle's serial or production number. This is unique to each vehicle and every manufacturer uses their own sequences as there is no fixed standard for this number. Check digit calculation. Check digit validation is compulsory for cars made in North America, as well as for all vehicles destined for sale in North America. It also may be used voluntarily by manufacturers who choose to do so for vehicle destined for markets where it is not required. In particular, it does not apply to vehicles not destined for the North American market, produced by the following manufacturers: Citroën, BMW, Renault, Audi, Korean Chevrolets, Fiat and European Fords, among others. If trying to validate a van with a check digit, first either remove the check digit for the purpose of calculation, or utilize the multiplicative property of 0 in the weight to cancel it out. The original value of the check digit is then compared with the calculated value. If the calculated value is 0 to 9, the check digit has to match. If the calculated value is 10, the check digit has to be X. If the two values do not match, then there is a mistake in the van. However, a match does not prove the van is correct because there is still a 1 in 11 chance of any two distinct van having a matching check digit. An example of this would be the valid VAN 5GZCZ43D13S8127115 and SGZCZ43D13S8127115. Note that the VAN in the Porsche image, WPOZZ99ZTS3922124, and the GMT body image, KLATF08Y1VB363636, do not pass the North American check digit verification. Transliterating the numbers. Transliteration consists of removing all of the letters and substituting them with their appropriate numerical counterparts. These numerical alternatives can be found in the following chart. I, O and Q are not allowed, and cannot exist in a valid VAN. For the purpose of this chart, they have been filled in with N, A. Numerical digits use their own values. S is 2, and not 1. There is no left alignment linearity. Weights used in calculation. The following is the weight factor for each position in the VAN. The 9th position is that of the check digit. It has been substituted with a 0, which will cancel it out in the multiplication step. Worked example: consider the hypothetical VAN 1M8GDM9A_KPO42788, where the underscore will be the check digit. The VAN value is calculated from the above transliteration table. This number will be used in the rest of the calculation. Copy over the weights from the above weight factor table. The products row is a result of the multiplication of the vertical columns, value and weight. The products are all added together to yield a sum of 351. Find the remainder after dividing by 11351. Mod 11 equals 10,351 divided by 11 equals 31 and 10/11. The remainder is the check digit. If the remainder is 10, then the check digit is X. In this example, the remainder is 10, so the check digit is transliterated into X. With a check digit of X, the VAN 1M8GDM9A_KPO42788 is written as 1M8GDM9AXKPO42788. Straight ones will suffice the check digit. This is because a value of 1, multiplied against 89, is still 89, and 89 divided by 11 is 8, with the remainder being the fraction 1/11, thus 1 is the check digit. This is an easy way to test a VAN check algorithm. VAN scanning. VAN may be optically read with barcode scanners or digital cameras, or digitally read via OBD2 in newer vehicles. There are smartphone applications that can pass the VAN to websites to decode the VAN. List of Common Wmi. The Society of Automotive Engineers assigns the WMI to countries and manufacturers. The following list shows a small selection of world manufacturer codes.